Seeing the manufacturing process of Japanese optical satellite glass finally made me understand why Musk says Japan is the birthplace of optical equipment. Musk wasn't wrong. A simple glass analysis requires controlling the smoothness of the inner layer and surface to nanometer precision, and it needs to cool for a month, making the crystallization process as challenging as chip manufacturing. If this were decades ago, it would definitely be considered the first step in a national level secret production. First, silica sand, soda ash, and lime powder are poured into a filter, and then they flow into a storage tank below after being screened. This process is very different from ordinary glass, because we all know that ordinary glass, petroleum, sand, and stone powder are a liquid inorganic product formed after melting at high temperature. But the glass ceramic in front of me looks strange. The picture shows a device used to mix raw materials. When the new type of roller rotates to the top, it is located in the tank, and the material is adjusted downward and begins to flow to both sides. When it rotates to the top again, the powder gathers together again. Only after earning the exact number of 7749 rounds can the worker hold the iron rod tightly and take out a bucket of powder. Align the lid, then pour it into the melting tank of the electric furnace and sinter it at a high temperature of 1300 degrees Celsius for several hours. The duration of this heating is closely related to the raw materials, and the temperature difference inside the furnace must not exceed 5 degrees, making it a closely guarded secret in every factory. In no time, the powder is completely melted, and a mechanical vehicle takes it out. Although this thing doesn't look very big in the video, you should know that it holds a full 200 liters inside. The melted liquid takes a long time to pour out completely, and then it has to be filled into every position at a horizontal angle. After that, it enters a cooling chamber to lower the temperature of the structure. You could say that the cooling process is very time-consuming. To this end, the factory is equipped with high-power fans next to it to accelerate the physical cooling process, which is faster than natural wind and only takes 1 hour. Then, 2 workers took crowbars and began chipping away at the glass, breaking it into pieces the size of rock candy. At this point, the initial raw materials for making microcrystalline glass have taken shape, but they can only be considered the most basic materials. The next step is where the most secrets lie. They first categorize the glass by size. Then add 10 different types of finished glass into the melting furnace, along with the crushed glass, to be melted together. To put it simply, you can think of it as purification. Just like the piece of glass you see in the footage, it has been melted for another 50 hours to take shape. Moreover, it has to be pulled out little by little using iron chains, and after a second purification and separation, there are no more bubbles inside, and it won't deform anymore. The key is that this material has a particularly high hardness. For this reason, the factory has its own clever method for splitting it apart. You can see the workers striking the surface forcefully with a chisel. Spraying again, he used some clear water, then lit the gas on his left hand with a lighter, and at this point, he could continuously roast the surface. It seems that the principle of thermal expansion and contraction has been thoroughly mastered by the experienced craftsman too. If you look closely, after roasting for a short time, it easily breaks in the middle here, completing the second purification. However, it cannot be used directly. It must be analyzed with an optical detector to assess the finished product. Now let's take a look at the transparency. Compared to ordinary glass, it's truly a world of difference. Only after inspection, when the glass shows no signs of starting issues, will it proceed to the next step of heat treatment. The so-called heat treatment is the process of changing the glass's rigidity through temperature to achieve a homogeneous treatment. In fact, it's somewhat similar to quenching in metals. By heating and cooling, the internal stress of the glass can be increased, thereby reducing the risk of shattering in special scenarios. However, the duration of the heat treatment takes a full 3 weeks, which means continuous heating for 3 weeks, followed by cooling for another 3 weeks. In addition, the refractive index of the glass will also reach an unprecedented level. Now let's take a look at why its heat treatment duration is so long. We all know that ordinary glass gradually expands after preheating, especially in the vast temperature differences in space. Therefore, scientists have developed another type of ultra-low expansion glass ceramic. For example, the James Webb Space Telescope features this material. Thus, glass ceramic perfectly addresses the drawback of glass expansion during preheating. Next, let's move directly into the third step of the process. After more than a month of heat treatment, the glass is taken by workers to the second floor and melted again in a dissolving furnace. From the outside, this seems no different from the first melting. However, inside, it mysteriously incorporates up to dozens of materials to adjust the crystallization effect and structural composition of the formed glass, and at this point, the temperature is as high as 1400 degrees Celsius. The mold also emits heat as the glass continuously generates thermal energy, then moves forward, preparing for demolding. But before starting, a thermometer must be used to measure it. Only when the temperature reaches the required specification can the workers in front remove the outer mold, cover it with a layer of insulating cotton, and secure a metal iron cover around the glass, thus firmly wrapping the glass to prevent bumps during transportation. Next, the forklift slowly lifts the glass, which weighs over 2,000 pounds, and carries it forward to enter the final heating step. This is also the critical moment that determines success or failure, as the heating and cooling process takes more than a month, so when this door opens again, it will be a month later. The reason the cooling time is so long is mainly due to the crystallization of the glass, which is a special property of zero-expansion glass ceramics. Let's take a look at the finished product after crystallization. It no longer has that initial transparent luster. Workers need to use a flashlight to inspect each position from top to bottom, mainly to check for bubbles in the glass layers. Only after all inspections are completed and passed, it will undergo double-sided polishing, 5-axis ball washing, ultrasonic processing, planar grinding, and slot cleaning, among other processes. After grinding, it will also be tested with a full set of data using a planar interferometer, 2-dimensional detector, and magnetorheological methods. Therefore, it will take half a year to be fully formed. So, what do you think this piece of glass is best suited for?